Hello, everyone. I wish you're having a great Thanksgiving break. So this video is to explain the details about the practice quiz 5. Still, there are multiple choices and then some analytical questions in the second section too. I already uploaded on Carmen, so please take your time to work on that. And I also uploaded the formula sheet just in case that you need it. Okay, today is very simple, and I hope this video can be very short and but also very clear so that you can understand what's going on. Let's get started. So first question, in which of the following cases will a bond sell at a discount? Sell at a discount refer to our slide. It means that the price is lower than the face value, or we call it par or principal, anything. So simply speaking, let's use P as price as the notation. It's smaller than the face value. Let's look at the choices one by one. So in A, coupon rate and the yield to maturity are the same. If you remember what we discussed about the yield to maturity, when the price equals to the face value, then the coupon rate and the yield to maturity are gonna be the same. So it's not at a discount, it means P equals to F. Please refer back to our slide. And this is the only thing that I might ask you to calculate the yield to maturity, but quote unquote calculate, because coupon rate, if it's given and if the bond is sold at the face value, then you should immediately know the yield to maturity is same as coupon rate. And as I said in class, it's gonna be very hard to ask you to back out the yield to maturity when in some more complicated cases. So I will not ask you to do the Excel or any like calculations, but this special scenario you have to know when coupon rate and yield to maturity is the same, it means the price equals to the face value. Okay, yield to maturity is less than the coupon rate. So remember, the higher the yield to maturity, the lower the price will be. On the other hand, if the yield to maturity is lower than the coupon rate, the price gonna be higher than its face value. So because of A, from A, we know that if yield to maturity and coupon rate are the same, P gonna be equal to F, right? But if the yield to maturity is lower than the coupon rate, then the price gonna be higher than the face value. So B is wrong, it's the opposite, okay? C is the right answer. Zero coupon bond have positive yield to maturity. So remember, for zero coupon bond, there's no coupon anymore. Price just equals to face value, discount back, according to its maturity date. Capital T here is the maturity. If the yield to maturity is positive, meaning this denominator is greater than 1, P will be smaller than F. It satisfies the concept or the definition of sell at a discount. So C is right. And on the other hand, D would be wrong. They are saying the opposite thing. But let's see, suppose the yield to maturity is negative. Negative yield to maturity. It means this denominator going to be less than 1. So if P equals to F divided by something less than 1, say, for example, if it's like if it's 0.99, then if P equals to divided by 0.99, it's gonna be bigger than F. Then it's sold at premium, not discount. So D is wrong, and that's the reason C is right. Okay. Question 2. All else equal, how does the maturity and the coupon affect the sensitivity of bond price to interest rate change? This is testing you duration. So remember, duration, by definition, it means the average time that you get your payment back, that you get your initial investment back. But on the other hand, as we mentioned in class, it can be used to approximate how much the price change when the interest rate changes. The formula that we talked in class is delta P divided by P approximately equals to minus D times delta Y. Delta Y is the change in yield to maturity divided by 1 plus Y, right? So remember, the higher duration means greater sensitivity. So the other way, in other words, this question is asking you what kind of maturity or higher or lower coupon rate will lead to longer duration, meaning D is higher and it's equivalent to greater sensitivity. So greater sensitivity again is equivalent to D is high, meaning that it takes higher or longer average time for you to collect your initial investment back. Okay, so then maturity gonna be very intuitive because longer maturity means you'll lock your money for longer term. So on average, compared to a very short-term bond, you take longer time to collect your initial investment back. So longer maturity is almost equal, is like approximately equivalent to higher the duration, right? And how about coupon? Remember the example I gave you in class. Suppose you have a 0 coupon bond and some coupon payment in the middle and a face value in the end, the bond A and bond B. Bond B has a lower duration because you start to collect more coupon in the middle. So 0 coupon bond is the extreme case that it has no coupon at all. It's the lowest coupon rate that you can get, meaning that the lower the coupon, if coupon is lower, it means you collect less money throughout the time before maturity. You collect less money, meaning that to get your initial investment back, it takes longer time. On the other extreme, if you have very high coupon rate, you collect a lot of money early on, then your duration will be shorter because it takes shorter time to collect your initial investment back. As a result, the answer is B, because as I just described, longer maturity and the lower coupon rate, they will both lead to a higher duration, which is equivalent to the greater sensitivity of bond price with respect to interest rate changes. Okay. Question 3. Again, so although in this section, some theories to explain the yield, the shape of the yield curve. In this section, I gave you some formula, but that formula is used to illustrate the idea. There will not be any analytical question in this section. What I expect you to know is to know the definition and the key idea or key intuition behind those theories. So I don't give you the formula, like equations on the formula sheet, because I don't expect you to like calculate anything. Okay, just to clarify. But as I showed you the practice questions in class, you have to understand, or like you have to know what is the intuition, what is the definition or the basic idea behind those three different theories. Something like this. This question 3 is another example, as very similar to what I gave you in class. Let's see. So expectation hypothesis theory of the term structure of interest rate. A downward sloping yield curve indicates the investor expect short-term interest rate to decrease or increase or no change. So remember, let's think about 2-year bond, 2-year yield to maturity versus 1 year. 1 plus y02, remember this is time t, time 0, which is current. This is maturity, it's 2 years. Squared should equal to 1 plus y01, meaning that a 1-year maturity bond at today and another 1-year maturity bond starting 1 year later. So they should be equal to each other because they are similar they should be like a same investment opportunity payoff, otherwise there's arbitrage. So when the left-hand side is higher, or like when the y02 is higher than y01, it means, oh no, not higher. It's downward sloping, so it means that this one is lower. Y02 is lower than like y01. What causes the problem? It must be because this part is low. Because suppose this expected future short-term or 1-year interest rate, if it's higher than current, higher than this y01, you're gonna expect this term, this 2-year yield to maturity rate will be higher than the current 1 year. But because the fact that it's downward sloping, it means next period, investors expect the new 1-year interest rate or new short-term interest rate to be lower than today. That drives down the 2-year yield to maturity. As a result, it decreases in the future. And also the other way around, if you observe some upward sloping yield curve, and if you believe in the expectation hypothesis, what is inferring is that the future short-term interest rate will be higher, will increase. That's the reason it drives up the long-term yield to maturity. Okay, this is just another, it's same idea as all the examples and practice question I gave you in class, but just to frame it in another way. Question 4. So 4 is very similar with 1. Question 1 is asking about sell at a discount. Question 4 is asking about sell at a premium. Sell at a premium means the price is greater than the face value. Okay. If coupon rate equals to yield to maturity, then P will equal to F. Price and face value will be the same. And we know the yield to maturity is higher, meaning price will be lower. They are negatively related. To make the price, so this all the choices A, B, C, D is trying to compare coupon rate versus the yield to maturity, right? Suppose you want the price to be greater than the face value because this is the definition of at a premium. Suppose the P is greater than the face value, P is higher than the equal scenario, then it means the yield to maturity should be lower than the equal scenario, equality scenario, meaning that it should be smaller than the coupon rate. Okay. So that's why A is right. It's equivalently saying coupon rate is higher than the yield to maturity. This is think through the lens of the relationship between price and the yield to maturity is negatively correlated. If you like mathematical equation, you can also think in this way. Think as if it's just a zero coupon bond. Price equals to F divided by 1 plus yield to maturity. Oh, okay. So, but you cannot have zero coupon bond because this one is comparing coupon rate and yield to maturity. But think about the general formula of the bond pricing, okay? So when does this price become higher? So in other words, think about some very extreme scenario. Price is really high, okay? Price is really high, meaning that the discounted back cash flow, the present value is much higher than the face value. One potential reason that drives it, like if you believe like F is given, F is just some fixed number. If price is very high, it means this coupon parts should be very high. If the coupon part is very low, usually the price gonna be very low because it doesn't contribute a lot, right? The extreme case is that zero coupon. So it's just discounting the face value all the way back to today. And if yield to maturity is positive, price gonna be lower. But think about some extreme case. If the bond is sell at a really high premium, like special case of sell at a premium, price is higher than the face value. What is driving it is coming from the coupon payment in the middle. And it means coupon payment should be high. High coupon means like future cash flow amount, even if you discount back, it has higher present value. It means coupon rate should be very high. As a result, coupon rate should be like greater than the yield to maturity. This is some qualitative way to think about it, like putting to an extreme case, because this question, when it says sell at a premium, it will include the scenario that sells at a very high premium. Then why does high premium come? It comes from very high coupon rate, and usually that's higher than the yield to maturity. So you expect the price gonna be very high today. Okay. And question 5. Consider the liquidity preference theory of the term structure of interest rates. On average, one would expect the investors to require what? Higher yield, like these choices are trying to compare between the short-term bond and long-term bond, right? Remember the key idea of liquidity preference. Key idea is the liquidity compensation. Why do the investors want to get compensated for the liquidity? Because they lock their money in a very long-term bond. There will be uncertainty. There will be uncertainty related to default or reinvestment or many things like yield interest rate changes. So this uncertainty or risk or opportunity cost will make the investors want to get compensated for the fact that they lock their liquidity in some long-term project or long-term bond. Because of that, there will be a liquidity premium that increases the yield to maturity of the long-term bond. In other words, B is right because this is exactly the definition. you would expect the investor to require higher yield on long-term bond because they want to, as I said, as I just explained, they want to get compensated for locking their money. They require higher yield if they have to lock the money for a long time. Okay, so that's why long-term bond will have higher yield than short-term bond. Okay, let's see 6. Consider 2 bonds, A and B. Both presently are selling at their par value. Okay, each pays an interest of $120 annually, or you can call it coupon. Bond A will mature in 5 years. Bond B mature in 6 years. And if the yield to maturity on both bonds change from 12% to 14%, what's gonna happen? If you look at ABCD, it's asking you 2 things. How does the price will change? And which one will be affected more? So yield to maturity increases because it changed from 12% to 14%. YTM increase, meaning that price decreases. It holds for all the bonds, both bond A and bond B. So both bonds will decrease in value. That's why A and B are wrong. The first part is testing you the relationship between yield to maturity and price. Second one is asking you which one will decrease more, bond A or bond B. The second one is testing you about the duration. Recall that formula, relative change in price is approximately equal to minus D times delta Y, change in yield to maturity divided by 1 plus Y. So this part is the same for both. Higher D, higher duration, means higher price change or more loss because of greater sensitivity. In other words, the second part is asking you which one has longer duration or bigger duration. This goes back to the maturity. Because bond A has a shorter maturity. In other words, B has a longer maturity and has a longer duration. So bond B will decrease more than A. Keep that in mind. The reason is because they pay the same interest rate and pay the same par value. So all the coupon and par value or face value are the same. So maturity will be equivalent to the duration. Longer maturity means longer term to collect the money back. So longer maturity bond will have longer duration and will be more sensitive to the yield to maturity change. As a result, bond B price will decrease more than bond A, and D is right, C is wrong. Okay, let's look at question 7. A coupon bond that pays interest annually has a par value of $1,000, matures in 5 years, and has a yield to maturity of 12%. If the coupon rate is 9%, the intrinsic value of the bond today will be what? This is a very simple question. It's literally just a plug in the formula. Which formula do we use? Because it has a maturity in 5 years, we use 5-year maturity bond pricing formula. So it's C divided by, I will just use Y to represent YTM, okay? 1 plus Y plus C 1 plus Y squared plus C divided by 1 plus Y third plus C divided by 1 plus Y to the power of 4 plus C divided by 1 plus Y to the power of 5th plus face value divided by 1 plus Y to the power of 5. Okay, and face value is $1,000, coupon rate, and it pays annually. Coupon rate is 9%, meaning that the coupon gonna be $90 every year. $90, $90, $90, $90. So for the first part, coupon part, you can use the annuity formula I provide you on the formula sheet, just to double check it, or you can just do like what I do here, manually add up everything. Okay. And this Y is 12%. So one thing, actually, because of the like choices A, B, C, D, numbers are very good. You actually don't need to calculate, but let's go through the very standard way. You just plug in those numbers, okay? Plug in all the numbers and you will get this result, $891.86. And this is the intrinsic value, and you just choose B. There's no like confusion or anything. It's just the answer, the analytical solution. But if you look at this question, before you plug in those, like plug in this gigantic formula before you start calculating things, if you read the question more carefully, read it twice. You actually can directly choose without calculating. Why? Let me show you. So again, remember what I told you. Suppose the yield to maturity is equal to the coupon rate. The price will equal to the face value. Here, the face value is $1,000, right? But you see the coupon rate is 9% and yield to maturity is 12%, meaning that yield to maturity is higher than the coupon rate. So the price will be lower than the face value. Let me repeat that. Price equal to face value is equivalent to yield to maturity equal to the coupon rate, right? These two are equivalent. And because we know higher yield to maturity will cause lower price, because here yield to maturity is greater than coupon rate, price will be lower than the face value. Your face value is $1,000. B is the only choice that satisfies this constraint. So B would be right. But of course, if you have time and you want to double check, make sure you're right, you can plug in this formula and calculate everything. And sometimes maybe the choices, there might be two numbers that both under 1,000. So you need to know how to do that analytically. You need to know how to plug in the number. But specifically for this question, you actually don't have to do that. Always keep in mind the relationship between yield to maturity and the price. Okay. Question 8. A bond has a par value of $1,000, time to maturity of 10 years, coupon rate of 8% with annual interest payment. If the current market price is 1,000, if the yield to maturity does not change, what would be the capital gain yield of this bond over the next year? Remember, so the answer is A, 0%. Remember the definition of the capital gain yield. What is it? It means B1, which is the price next year, divided by B0, which is the current price, minus 1. This is similar to your first formula sheet in midterm. The capital gain yield comes from the price appreciation. Sales price divided by buy price minus 1, because you want a yield, you want a return. What would be the current price? Current price is told, like it's given, it's $1,000. So you know B0 equals to 1,000. The question is, what is B1? That's the tricky part of this question. So because you know the current price equals to the par value, it goes back again to the argument that I emphasized so many times. When the price equals to the par value, what does it mean? It means the yield to maturity equals to the coupon rate, right? It implies that yield to maturity equals to coupon rate equals to 8%, because coupon rate is 8% in this question. Okay, now time flows. We are at the end of next year. We're next year now, 1 year later. If the yield to maturity doesn't change, and the coupon rate doesn't change, it's always 8%. The argument still holds. 1 year, it is irregardless of how, like what time you are, how long the maturity is, as long as the yield to maturity equals to the coupon rate, the price is always same as the par value. Okay, this is the tricky part. So 1 year later, because yield to maturity doesn't change, it's always same as the coupon rate. The price will still be the face value, which is $1,000. As a result, B1 will be $1,000, right? So because B0 and B1 both are $1,000, your capital gain yield would be 1 minus 1 equals to 0%. This is why the answer is 0%. But let's take a step back. I already gave you the answer. We finished this question, but think about this. Suppose the yield to maturity doesn't change. Why do you want, like price doesn't change? Why do you want to hold this bond? Because you don't get any price appreciation, right? The reason is purely because of coupon. Through this year, you will get $80 of coupon. If you buy more, you will get more, right? Because it's always 8% of total money you invest. Suppose yield to maturity does not change. It's constant forever. Price never fluctuate. You can only gain from the coupon rate, or if you use the like equity valuation for context, it's like the dividend payout. So you just eat the fruit outside, like dropped from the tree. You just eat the coupon, consume the coupon each period every year without getting the price appreciation. Okay, that's the only gain that you can get if the yield to maturity does not change, and which means it's always same as the coupon rate. Okay. Question 9. You can be sure that a bond. Okay, I think I duplicated this question. So question 9 is the same as question 4. So I will not spend the time. Yeah, it's a typo. It's duplicated. So ignore question 9. It's the same as question 4. Then let's go to section 2. So I believe I already put all the intermediate steps here, like one by one, little by little. So if you go through all the details, you should know how to solve the question, because most of them are just analytical. But let me quickly go through, okay, to make sure you get it. Let's see the problem 1. On January 1st, 2017, you buy a 3-year annual pay coupon bond with 6% coupon rate, $1,000 face value, yield to maturity 6%. 1 year later, you receive the first coupon of the bond, and another year later, you receive the second coupon. Immediately after receiving the second coupon, you sell the bond. and assume that the yield on the bonds of all maturities are equal to 4.5% on January 1st, 2019. Let's do it step by step. What is the price that you pay for the bond on January 1st, 2017? This is just plugging in the formula C divided by 1 plus y, C divided by 1 plus y to the power of 2, C divided by 1 plus y to the power of 3, plus F divided by 1 plus y to the power of 3. And because it's a $1,000 face value, coupon is $60, $6 C, and you can combine C plus F together, which will be 1,000 plus $60. Okay, so it's just 1,000. It's not surprising because you see the coupon rate is the same as the yield to maturity. Both are 6%. What is the selling price of the bond on January 1st, 2019? So on the January 1st, 2019, after you receive the coupon, starting from January 1st, 2019, you only have one principal, which is this part, one principal and one coupon at the same date on the maturity date. So you only expect 1 year later, you receive $1,060 because you already collect the first two $60 coupons. And because it's gonna mature 1 year later, you discount it back by 1 year. And remember, when you immediately sell the bond, the yield was not 6% anymore. It decreased to 4.5%. As a result, the sale price would be the leftover payment, which is the face value plus the last coupon payment, discounted back by using the new yield to maturity, which is 4.5%. And the new price will be $1,000 for $1,014.35. Okay. What is the value of the January 1st, 2019 of all the coupon payments that you have already received? Remember, you received the first two $60 coupon payment as a part of bond. So suppose it is asking you, like, suppose every time after you receive the coupon, you immediately invest it. Okay. Remember, you get the first coupon payment in 2018. That's the first coupon payment. And that one you can reinvest for 1 year all the way to 2019. And in 2019, you will get another coupon payment, which is the $60. So on this date, this new coupon payment does not need to convert along the time because it's just a current cash flow. And the second one is assuming like this is coming from 2018 and assume you reinvest it at yield to maturity 6%. 1 year later, how much it is? It's $60 times 1.06. So together, the value of the coupon will be $123.60. Okay, just to repeat, this first part is because you just get a coupon on exactly this day. So it's just a cash flow. You don't need to convert along the time. But because this $60 you got in 2018 is the first coupon you get, you have to reinvest and convert it to 1 year later on 2019, assuming your investment yield is 6%. Okay, so what is your annualized HPR on your 2-year bond investment? What is that? So it's gonna be, remember, HPR is B0. Oh, no, sorry. B1 plus the coupon part, C1 divided by B0, right? Again, the B0 is the buy price. The B1 is the sale price of the bond. And this part is all the coupon value at the end of the holding period. End of the holding period means 2 years later, in 2019 January 1st. So we calculated the sale price, which is $1,014.35. And in 2019, the value of coupon is $123.60. Okay. Oh, and it should be to the power of 1 divided by t minus 1. So this t, because you want to annualize it, holding period return should be annualized. And this t gonna be 2 year here, because you want to annualize, like convert it from 2 year total return to 1 year annual return. So you need to take a square root minus 1. It's gonna be 6.67%. So you see your holding period return is actually higher than your yield to maturity, which is 6%. There are two parts that give this result. The first one comes from the capital gain yield, because right after when you sell the bond, the new yield to maturity is 4.5%. It is lower than your initial yield to maturity, meaning that the price appreciated. The new investors cannot earn that high yield to maturity anymore. So you gain some capital gain from the bond price itself, change of yield to maturity. At the same time, you will gain some value, some return from the coupon reinvestment, because you reinvest it, at least one coupon payment, although it's very small, but you reinvest it at 6%. So the reinvestment will give you more value of coupon rather than just holding it. So altogether, it gives you a holding period return, or the true realized return, that is greater than the yield to maturity. Okay, this is just the answer of this question, but I want you to take one step further, try to recall what we covered in class. I told you that yield to maturity and the holding period or realized return are the same if and only if there are 3 conditions, right? The most important things are like you hold it until maturity, it does not default, etc. So go back to the slide and review those 3 bullet points. And yield to maturity is constant over the time, something like this. So because, and if you look at this question, 2 of them are violated. First of all, yield to maturity did not remain constant. It changed, it decreased. And secondly, you don't hold it until maturity. You sell it in the middle. Then the realized return, here we call it holding period return, will be different from the expected yield to maturity when you buy the bond, which is 6% in this example. In this case, because the new yield to maturity is lower, meaning that there is a price or capital gain, capital appreciation, and plus you reinvest your coupon, it's all good news. So your holding period return is higher than what you expect to earn. Okay, so that's just try to link it to the slide, like how it is related, because I might ask you some qualitative questions in the final exam. Okay, problem 2. So 1 year zero coupon bond is selling for $900, zero coupon, 1 year. Well, the face value of the bond is $1,000. The investors expect the company will likely default, and the expected payout is only $970. In other words, the face value, when the issuer promised you to be $1,000, but you did some maybe rigorous research or you have some information, insider information, you know the firm is not actually doing well. So you actually are going to face the risk of default, meaning that you don't collect the promised face value of $1,000. You only collect $970, which is lower than your expectation. Calculate the default premium. Hint, difference between the stated yield to maturity and the expected yield to maturity. The stated yield to maturity is the one comes from the face value. Stated is the one like issuers promised you. It's very simple because it's zero coupon bond. So the yield to maturity, there should be -1. So this one is 1,000 divided by 900 minus 1. Okay, it's 11.11%. And here also -1 equals to $970 divided by 900 minus 1. So expected yield to maturity comes from after your research, your rigorous research. You expect the firm to default and you expect you only collect $970. So within your expectation, the yield to maturity will be lower than what is stated or what is like quote unquote promised by the issuer. It's only 7.77%. The default premium is the difference between the stated YTM and the expected YTM, which equals to 11.11% minus 7.77%. And you get the result 3.34%. This is just the analytical part. You just calculate it. What does it mean? What it means is in question B. So if you had to explain the default premium to your grandmother, who presumably does not know anything about finance, how would you explain it? So to grandma, let's see the correct answer. If someone asks you for money and promise to pay it back with interest, you might be worried that they won't pay it back. Because of your concern, you won't get it back. You might ask them to increase the interest rate from what they said initially. Okay, so think about it through the price channel. Suppose a firm promise you to give you $1,000, but you don't really think they can repay you $1,000, and they will repay you less. What will you do? You won't be willing to pay very high price for that bond if the bond might default in the future. Suppose for firm like suppose there's a bond from Google, and let's assume Google don't default. Okay, suppose there's a bond from Google with face value of $1,000, and you know Google will not default. You think it's not possible. It's not gonna default at all. So for this $1,000, you expect the firm, you expect to pay, say, $900 to get this $1,000 face value. This is the price. Suppose you don't expect the firm Google to default at all, and because of your opportunity cost, your like time value of money, you think $1,000 in the future worth $900 today. Okay, but for another firm, let's call it ABC Inc. It's about to default. It also has a bond with $1,000 face value, but it's exactly the same bond like same structure as Google's bond, but will you be willing to pay $900 for that? You might not want to do that because you don't think they can repay you $1,000 in the future. You don't trust them. You think they might default. Then what you do is you might buy it at, say, 850, smaller than 900, because you expect them to repay you less. So you want to pay less today. And if you calculate the yield from Google and the yield from ABC, you will find the yield to maturity on ABC will be higher than Google. Google is default free. ABC has some default risk. And those higher part is the default premium. So it's just a detailed or more detailed illustration on this paragraph. So if someone asks you for money and promise you payback, but you don't think they can do that, you will ask them to increase the interest rate. It's equivalent to decrease their price, because the lower you pay today, the higher yield to maturity or the higher interest rate you're gonna get. So you require them to increase the interest rate, meaning that you want to pay less today. And that increased interest part is the default premium. Okay. So this will conclude our practice quiz 5. And again, it's next Monday, still at the beginning of the class, and it only covers chapter 6. And yeah, just again, it will include the practice quiz 5 and also the slides, all the analytic question and the practice questions in slides, everything. So, but I wish you have a great Thanksgiving. And although I believe many of you, when you watch this video, it's already after Thanksgiving, maybe right before the quiz, but good luck anyway. And hope you enjoy the lecture. Bye-bye.